So we've made it to chapter 4. Chapter 4 is about exponential functions and logarithmic functions. These are two things that sort of go hand in hand. And 4.1 is about exponential functions. So we'll start there. An exponent, right, usually means for us to do repeated multiplication. We've seen a couple different exponents, but in general, right, squaring, cubing, raising to the 4, those are kind of our go-to exponents, and it means to sort of multiply your base number by itself however many times. So what we're going to be doing is defining here. So the form for us is going to be a function f of x where the variable, right, so to be an exponential function is not going to be something like a function that has variables, right, x squared, x cubed, all those kind of things that were polynomials. Obviously there are exponents involved, but the idea here is to be an exponential function is that you're taking some sort of base value. We'll use sort of b here as just a generic constant, and it's raised to the x. So the b value here is a constant, some sort of constant number, right? 3, 5, 10, 1/2, 1/3. You could do a lot of different things. The restrictions are, so this is going to be where, so the value for b is greater than 0, and we're going to ignore the case where the base value is 1. 1 to the x is kind of a trivial function, right? 1 raised to the anything is just going to give us 1 back again. So 1 to the x is kind of a trivial function for us. So we'll be looking at things that are more like, so f of x is maybe, right, 2 raised to the x, right, 4 raised to the x. We could do some fraction kind of things like, 1/2 raised to the x. Generally speaking, exponential functions, they're going to grow and get big very quickly. They're going to sort of grow and get bigger faster even than polynomials. That whole idea of exponential growth, right, is sort of something just day to day that people sort of use in some sense to just mean like quick growth. Technically, it's this idea, of something, you're thinking of cells dividing or some sort of like virus spreading where you sort of infect 2 people, and then they infect 2 people, and they infect 2 people, and they infect 2 people, and so on and so forth. And the spread and the growth, right, this sort of exponential growth, gets very, very big, very, very fast. So that's the kind of behavior that we're looking at. What we're doing in 4.1, really more than anything else, is we're going to be trying to make some graphs. We're going to try to visualize what these exponential functions look like. So let's make a graph of this sort of first example. F of x is like a 2 raised to the x. And let's just use a table of values. So let's just sort of make a graph. We'll make a table just to visualize a little bit, like this as kind of an example function. What is this going to look like? And then we'll see how much we can generalize that to other examples where the base value is something different. Obviously bigger numbers, 4, 6, 8, 10, 100, a million, 1,000, or smaller values like a 1/2, a 1/3, a 1/10, things like that. So let's pick a couple x's to put in. The idea here is that all of the x's are going to be exponents, right? They're all sort of going into our function, and so the y values are going to be what we get out of it. So in some sense we can sort of use our normal sort of go-to values. We could sort of just start maybe kind of 3, 2, 1. We could do some fraction stuff, right? We can do fraction exponents. We're not necessarily going to need them. I'm actually going to sort of ignore them for now. So let's just do kind of 3, 2, 1, do 0, to -1, -2, -3. My kind of default is to have us use kind of 2 to -2 is like a starting point. I'm expanding this just a little bit because this is sort of new for us. So we'd like to sort of see what happens here. So let's just kind of plug these guys in and see what we get. So this is going to be, right, so f of 3, 2 raised to the 3, and so we're just jumping right into applying our powers, right? So 2 to the 3 is 2 cubed, 2 times 2 times 2 is going to be 8. So an x value is 3, the y value is going to be 8. We'll just keep this going. Let's just kind of fill this in relatively quick, right? X is 2, so that means we're doing a square. 2 squared, well, 2 times 2, right, is going to be 4. If we're raising it to the 1, that's sort of an identity, right? 2 raised to the 1 is just back to 2. 2 by itself is 2, okay? So 1 comma 2. What do we get when we raise something to the 0? The idea is that anything raised to the 0 is going to get us back to 1, right? So 2 raised to the 0 is going to get us to 1. A little bit of a funny property, the expectation I think for a lot of folks is if you raise something to the 0, you would get a 0 back. But we'll actually see when we graph this sort of 0.01 is going to be a common point to almost all of our exponential graphs. And you can see how it will sort of fit into the pattern nicely. 0, 0 would actually not fit in very well. Quick refresher, right? What happens if we start putting in negative powers? So -1. And the answer is, right, it flips and it becomes a fraction version. So it doesn't give us a negative number, right? It gives us this fraction version of the thing. So it's 1 over 2 to the positive 1. So the idea here is that, you know, we don't really have a way to sort of multiply something by itself -1 times. Just kind of conceptually doesn't make a whole lot of sense. I sometimes think of the negative powers really as like a division more than anything else. Hey, bud. Oh, Max, please don't jump up here. Thank you very much. As always, cats are very happy to help with the work. Let's do -2 before we get totally overrun. Whoops, this is just like a little bit out of sight. I'm crunching in here a little bit. That's okay. Sneak this down here. So 2 to the -2, so that's going to be 1 over 2 squared. So that's going to get us 1 over 4, right? So it becomes a fraction. Oh, I'm sorry, I didn't mark them over here. This was 1/2. This is 1/4. You can see the connection when everything is laid out, right? We're getting fraction versions of the numbers we had before, right? Reciprocal versions, 1 over 4, 1 over 2. You can imagine, right, if we do -3, we're probably going to get 1 over 8. We'll just sort of do this for completeness sake. -3, 2 to the -3. 1 over 2 cubed is going to be 1 over 8. So what's happening here, the sort of pattern we're developing is, right, for the positive exponents, we're getting sort of positive numbers out of it. The negative exponents, we're getting positive numbers out of it, but they actually get sort of smaller and smaller. Again, they have this sort of inverse kind of reciprocal relationship relative to the values that we were getting out for the positives, right? They kind of mimic each other, but it's a fraction, it's a 1 over version instead. And then in the middle we have, right, when x is 0, we just get this positive 1 as kind of a middle point. If we were going to do a sketch, I'll do this a little bit kind of loose. And one thing here, right, that we can kind of anticipate is we're not going to hit any negative y values, right? No matter what exponent we put into here, we're only going to get a positive number out of it, right? If it's 2 raised to the anything, you're either dividing by 2 or you're multiplying by 2, positive 2, so you're only going to get positive numbers out of it. So we don't really need to mark our graph underneath the axis here, so that saves us a little bit of space. 1, 2, 3, 1, 2, 3. We have a little bit of a scaling issue, right, where we have both, you know, relatively kind of, you know, bigger numbers like 8, but then we also need to graph things like 1/8, 1/4, and 1/2. I'm going to kind of split the difference here. Let's maybe scale our y's up to 4. And so maybe this sort of 3 and positive 8 is just not going to end up on our graph this time. That'll be kind of off the charts a little bit. So what are our values here? I'm actually going to start in the middle. So 0, 1. So again, this is going to really be almost like our sort of touchstone point. That's going to be a point that's common to almost all of our exponential graphs, because whenever you raise something to the 0, the idea is you're going to get 1 out of it, a positive 1 out of it. If we move ahead, so when x was 1, the y value is 2. When x is 2, the y value is 4, right? And then when it's 3, it would be, positive 8, which is sort of, ballparked to be maybe somewhere up there. Negative 1, we're at 1/2. These again are going to be very kind of loosey-goosey, 1/4 and kind of 1/8. And so what's happening here is we sort of go into our positive values. Obviously, we sort of increase and we go up and up and up and up and up, steeper and steeper and steeper. Right? So we're sort of heading towards positive infinity as we move to the right very, very quickly, just getting bigger and bigger and bigger. To the left, what's happening is we're leveling out, right? Our sort of graph is flattening out, and we're getting smaller and smaller and smaller y values, right? 1/2, 1/4, 1/8, and so on and so forth. We're never going to hit 0, so we're going to have asymptote to the left, right, at y equals 0. We're sort of flattening out here. If we were graphing this in the homework, we'd sort of put in the full dotted line here on the axis as our asymptote. Again, that sort of ideal kind of reference point, our sort of touchstone coordinate, is that 0, 1 right in the center. And we go from there. So that would be 2 to the x. So this is 2 raised to the x. And this is sort of, one of our more standard exponential graphs, our exponential functions. What we're going to see here in general is we're going to have this kind of rises up to infinity and then flattens out on the other side and goes through the center here at 0, 1. So that's a start.